Hey guys, welcome back. This is a surprise. We got another question. We've got the surface area S of a cylindrical tank with a hemispherical top is given by the formula S equals AR squared plus BRH. That's a lot of variables. We've got 1, 2, 3, 4, 5 different variables. R is counted. R is there twice. There's an R squared and a regular R. Where A is 9.42, B is 6.28. What is the radius of a tank of height 6 meters, which has a surface area of 125.6? So the question wants us to find the radius, R. Now that, probably not a shock, it's quadratic. We know A, we know B, we know the height, and we know the surface area. So we know everything except R. So this tricky looking equation, we just have to sub everything in and see what we get. So S equals AR squared plus BRH. So S is surface area, so that's 125.6. A is 9.42. We don't know what R is, so we leave it as R squared, plus B, which is 6.28, times R times 6. I can multiply the 6.28 and the 6. So 125.6 equals 9.42 R squared plus 6.82 times 6. That'll be 37.68 R. Okay, so we've got, this is a quadratic. We have R squared, we have R, and we've got a constant, but it's on this side of the equation. So we can make this equation equal 0 by subtracting 125.6. So 0 equals 9.42 R squared plus 37.68 R minus 125.6. This is a quadratic with a value of 9.42, a B value of 37.68, and a C value of negative 125.6. So that would mean that if we want to solve for R, we could try the A, C, B method, the factors of A times C that add up to B. But we're dealing with some pretty intense decimals here, so I can't do that in my head. But what I know will work is the quadratic formula. X equals, but in our case it's R, so let's write R. R equals negative B plus or minus the square root of B squared minus 4AC all over 2A. Now, I'm going to let you guys work this out, but I will give you a hint for later. One of your R values will probably end up being negative. Can we have a negative radius? I'll leave that up to you guys to decide. Anyway, you've just got to sub in your A, B, and C values and solve. That's it for now. Thanks for joining me, and I'll see you next time.